Here we are going to talk about forces, right? So forces basically it consists of several topics, right? Let's say balanced forces. Then we have to talk about unbalanced forces, right? Unbalanced forces, and in unbalanced forces, I will tell you what to do. Is that screen shared?
Yes, sir.
Yes, sir.
Okay. Then we have to talk about movements. Then we have to talk about momentum. Okay. Then we have to talk about pressure. Then we have to talk about deformation. So this all is actually related to forces. And then finally, although that is a next topic, but work is a effect of force. So we have to talk about work, energy, and pressure, work, energy, and power. Okay, so this is a long way to go with forces. So please, if you people are aware of the concept of the basic forces, then it would help you out till this point. Got it? So let's say we talk about balanced forces. Okay, when we talk about balanced forces means when when a body is applied on a when a force is applied on a body, there is there are all forces having no net impact, or all forces are having no resultant force, right? So first let me talk about an introduction about the force. So what a force is, can you define it? Anybody? A push or a pull that can change, I mean it sometimes it change and sometimes it does not, but it can change what state of motion, right? Direction of motion
Yes.
and
Shape.
shape of the body. Yes, is it shape of body? So overall I can say that force can cause, so simply what can a force do? Force can cause, or force can produce. In simple words, there are two main impacts which can be produced by a force. One is acceleration, okay? The second one is rotation. Are you agreed with me? And third one is
Yes.
deformation. So these are actually three impacts which can be produced by a force. When we are talking about a force, force can produce this. So force is represented by F. You people are very much aware of that. Its symbol is F and its unit is Newton. We can write this with small n e o w t o n. It's Newton. And in the next topic I will talk to that whether force is balanced or not, but I believe this thing that you people are known with this F is equals to ma, both of you. That's why I can refer that. Measurement of force or quantification of the force is very important. Measurement of force is done by Newton meter, right? Force is done by Newton meter. It is called spring balance, if you remember, right? We usually call
Yes.
watch it spring balancer. It is called Newton meter. Okay, so we can measure this force by this. Its shape is something like this. Let's say this is a case, and then we have a hook over here, and then we have some readings over here. Okay, 0 1 2 3 4 5 6 7 8 9 10. Okay, and 11 12 13 14 15, and there is a hook over here. So with the help of a pointer we can move, or we use a pointer over here. There is a slides in this path. So when the pointer moves across this, it reads the value of force. Usually it is used to measure the load, right? So this is a Newton meter. It is used to measure, but calculations of the force are actually based on F is equals to ma. Do you know this thing? That was measurement what I talked about, but calculations are
Yes.
based on by F equals to ma. How do you calculate the force? By using F equals to ma.
Um,
So when I say that what a force F is, that can be simply a force, and then m is the mass of the body and a is the acceleration. So I can say that force will be 1 newton. Force is 1 newton if it produces 1 meter per second square acceleration in 1 kg body. If it produces an acceleration of, are you getting this thing?
Yes, sir.
Produces an
yes, sir.
acceleration of 1 meter per second square in a mass of, in a mass of 1 kg. So then you will say that how I have this much force. So for example, it's very simple now. If it is 1 kg body and it has an acceleration of 1 meter per second square, then definitely force will be equals to 1 newton. But if same thing is producing an acceleration of, let's say, 2 meter per second square in a body, so that force is equals to 2 newton. So it's very simple to understand the basic concept of the force, but we have to handle the forces in different ways. That force is a vector or a scalar. So the next thing you should know about the force, that force is, what a force is. Force is a vector. Okay, force is a vector quantity. So you know,
Vector.
it always act in a specific direction. For example, if you have a block and you are going to apply some force in that, on that, it would act in this direction. But if there would be another force acting in different direction, either opposite or in same or whatever, that would be considered as a different force. So let me call it F1, F2, F3. There can be different forces, right? F4 and so on. So they all are in different directions. So without consideration of the direction, you cannot consider or you cannot understand the force. So remember this thing, that when we talk about force, force is a vector. So force is represented by a vector. Force is represented by a, represented a by an arrow, right? Arrow means, right, simply like this. There are two important things in this arrow. One, the length of the arrow. Okay, length shows magnitude of the force. What does this length show? The magnitude of force. Okay, and what about the direction? I head shows direction. What is the direction? It is represented by head. So these are two very important things. I think you people are well known with these two. Let's talk about handling the force. Okay, handling a force as vector quantity. Okay, so when we are going to handle the force as a vector quantity, we have to consider that whether this force is in specific direction. So I have to consider that, okay, let's say, uh, definitely there would be more than one forces. So first of all, it is called the vector, or yeah, vector representation of the force. So it is graphical representation. Actually we call it graphical representation, right? Graphical representation or graphical method. Are you getting? Graphical representation of graphical method. So in this method, let's say you are having a force acting in one direction. You have to show that force, that okay, how much length does it have and how much or which direction does it have. So for that purpose, we need scale. What do we need? Need scale, right? Scale shows that 1 centimeter long vector shows how much newtons. Okay, this means show scale. 1 centimeter long vector is equal, or 1 centimeter long vector shows how much newtons. Yeah, or how many newtons. Is this clear to both of you?
Yes, sir.
Right?
Yes, sir.
This is scale. So, for example, if I say that if the scale is 1 centimeter is equals to 50 Newton, so it's very obvious that the length of 1 Newton vector, it is equals to, let's say it is 1 centimeter. Suppose if it is 1 centimeter, it is representing 50 Newton force. But if the same vector is having the length of 2 centimeters, right, from this point to this point, it is 2 centimeter. This will show you 100 Newton. Are you getting it?
Yes, sir.
Yes.
Yes. And then we have to now, that direction is placed with the help of protector. Direction of force is placed by protector. What is a protector basically? D जिसको कहते हैं. It is your D. It is basically in your mass box. So you can say, for example, if I have to place a force over here, this is usually the force along x-axis is the reference force. So let's say this is the force along x-axis, and I want to place a force along y-axis. Sorry, at certain angle. So I have to place a D over there. Although I don't have this D in my toolbox of this software, but I can show you that this can be D type thing, and then we will place it over here this way. Okay, this would be exactly at 90 degree, this would be exactly at 0 degree, this would be exactly at 180 degree. These are basically some important positions of your D. Okay, and then you have, suppose this is your 45 degree, this is your 135 degree. Then it would be divided into three: 1 2 3 4, 1 2 3 and 4, 1 2 3 and 4, 1 2 3. So this is basically your D. So let's say if I have a force of, suppose, how many centimeters? 1 2 3 4 and 5 centimeter. 5 centimeter means how much newtons? According to the upper scale, it is 5 times 50 Newton. Basically this is actually 225. Is it 2250?
Yes, yes, sir.
Yes. Yes. So this is, sorry, I think it's wrong. 250 newtons. Okay,
Okay.
250 Newton. So if I want to place another force at 45 degree with this, right? So I would use this D and I will plot it. Let's say this is 1, 2, 3, and suppose it is 4 centimeter. 4 centimeter, I means 200 Newton. So this is what, how to place the forces. So now these two forces are placed over there. So it was just a small idea how to place the forces. I'm not, I have not yet reached that how to add them or subtract them, but this is what, how to represent the forces. Is this clear to both of you?
Yes, sir.
Yes, sir.
Okay, now forces in the same direction are added. Very simple. You people know this thing. Forces in same direction are added. Okay, they are added together. So I can say that if we have two forces in the same direction, I have to add them directly according to the scale or according to the values we have over there. Let's say I have these two forces. This is of 50 Newton, and suppose this is of 60 Newton. Then the resultant would be equal to 110 Newton in the same direction, right? So it's very basic thing to emphasize that force is F1 plus F2, but forces in the opposite direction are subtracted. So second thing is forces in the opposite direction are subtracted. Forces in opposite direction are subtracted. When there are forces in opposite direction, they would be simply subtracted. Are subtracted. Yeah. Is it clear?
Yes, sir.
Here I have mentioned this, that same direction added and
Yes.
opposite direction they would be subtracted. So when the forces are subtracted, let's say you are having two forces. One force is acting on a body which is 50 Newton towards left, and there is another force which is 70 Newton, or sorry, let's say it is 120 Newton towards right. Then what will be the resultant would be in this direction, and it would be 120
7.
minus 50, 70 Newton. Okay, so we can simply say that in the opposite direction F net will be F1 minus F2, or F net is equals to F2 minus F. So this is what we used to do when the forces are in opposite direction. But third case, when the forces are perpendicular to each other, perpendicular forces. Okay, perpendicular forces. So the perpendicular forces are actually the forces when they are at right angle to each other, right? Forces at 90 degree, forces at 90 degree with each other. So let's say I have a force in this direction. Suppose this is a force, and suppose it is 100 Newton force acting over there, and there is another force acting at right angle to this force. Suppose this is your 60 Newton force. So how to find the resultant of that, or how to add them together, or how to process them? It is basically, it it has two methods. Method number one is graphical. As I am discussing graphical one, so graphically we have to place the replica of this vector, blue vector, on the head of this, which is called your head to tail method or parallelogram method. I have placed this 60 Newton on the head of this red one, and then 600 Newton on the head of this 60 Newton. So this is basically a parallelogram, right? So in this method, uh, prepare a parallelogram. What to do? Prepare a parallelogram. Are you getting it?
Yes, sir.
Yes, sir.
Okay, we have to prepare a parallelogram. So parallelogram is clear by replacing or by providing the same vectors on opposite sides. So resultant will be starting from head of, sorry, tail of both tail of both vectors. It is your tail junction. What is that? It is your tail junction. And then the this point is head junction. What is this? This is your head junction. So what is the resultant direction? Resultant is from tail junction to head junction. Tail junction to head junction. Are you getting it?
Yes, sir.
Okay, so
Yes,
don't
sir.
don't forget this method. It is very simple to understand that it would be from head, sorry, from tail of first to the head of last, or you can say from tail junction to the head junction. This is your resultant. Now, as I told you that this is a graphical method, so this is just to draw. Then magnitude depends upon something different. The is magnitude depends upon scale. Okay, magnitude depends upon scale. So magnitude mean first you measure the length and multiplied by scale, multiply by the scale, right? I will explain it, don't worry, with the help of diagram. So you have to measure the length of that resultant and scale, multiply it with the scale, it that is equals to magnitude of the resultant. Okay, magnitude of resultant. But usually, we have a very easy approach over there. There is a method to numeric method. Okay, method 2 is your numerical method. Numerical method is actually, what is a numerical method? It is your Pythagoras. Okay,
जी सर.
by using Pythagoras theorem or Pythagoras method, this is actually a right angle triangle. It becomes a right angle triangle. This one is your uh, f1, then this becomes your f2, which is at the head of this is your f2, and this one is your resultant. Okay, this is your resultant. So how to apply the Pythagoras theorem? If you help me out to figure it out, resultant square is equals to f1 square plus f2 square. Why? Because this is base of the triangle, I mean adjacent. This is your perpendicular of the triangle or opposite, and this is your hypotenuse of the triangle or resultant. So I can say that hypotenuse square, because it Pythagoras theorem says that hypotenuse square is equals to base square plus perpendicular square. Is it? Do you believe this thing?
Um, yes.
Yes. So, for example, in the above equation, if I want to find resultant, I have to take square root on both sides, right? And by taking square root on both sides, I would get this r root f1 square plus f2 square, and luckily this would be gone. So your resultant is equals to f1 square plus f2 square root. Clear? So let's say if I have this force, this was equals to 100 Newton, and what was the magnitude of this one? It was equals to 60 Newton. So I will just put the values 100 square plus 60 square root. So what will be its answer? Can you calculate it, please? Yes, please.
Just
116.619.
Yes, 116.6, which is basically
619.
117 Newton. Okay.
yes. Okay, sir.
Yes, sir.
Got it?
जी sir.
Now, this is basically that method in which we can handle till three types of forces: same, opposite, and perpendicular. But generally, forces are not in this way. Generally, forces are in any direction. Forces can be in any direction. In any direction. So when the forces are in any direction, right, we use graphical method, and in that graphical method, what will help us out, graphical method is used till your level. Okay, method is used, right? What are the tools required with you people for this method? One, you need a scale. Second, you need a pencil. or a pen, it does not matter. Third, you need a protector. Fourth, you need a compass. Compass or compass, which is basically in the in that math set. This thing,
Yes.
Yes, sir.
yes. So we need these four tools with us. So how to handle that? First step, I will write some steps also, and then we will basically do some of the question steps. First, draw the vector diagram. Draw scaled vector diagram, or you can say first scale the force. Scale the force. Do you know, I told you that how to scale it, that its scale means 1 centimeter equals to this much. So scale the force. Second thing, draw the vector diagram. Vector diagram. Third, complete parallelogram. Okay, complete parallelogram. Assalamu alaikum. Sorry, I think I was disconnected. So where was I disconnected? Did you remember some point?
Step number 3.
Oh my God. I was very enthusiastic that I have read all of the steps for you people. Okay. So I was at this step. I mean, I will explain these all steps to you back. Scale the force, right? First, you have to scale the force. I mean, 1 centimeter is equal to this much. Then you have to draw the force vector diagram. Then you have to complete the parallelogram. Then you have to draw the resultant. That's why I have read this with. I have written this with red. Then measure the length of the resultant. This is very important step. Then multiply the length with scale. This is another very important step. And then for last step, direction, you have to use dr protector to find in which direction the resultant is. How is it clear?
Yes, sir.
Okay, yeah, is it clear?
Yes, sir.
Okay, let's have a practice question. I would draw that on the squared box like this. Okay, now this is basically a graph for you people. Here, practice question, our example is, let's say I have two forces, or I have two forces acting on a rod or acting on a board. Let's say we start from the board. Suppose this is a block or a board, and there are two forces acting on it. One force is applied in such a way that it is at certain angle. I would mention that angle. Okay, this is not the scale diagram, it is just a diagram. It's not even the vector diagram also as well, right? Then there is another force, and that force is acting on that in certain direction. I will show you those directions, right? I will name these forces, and I will name the angles and all that stuff. So the direction of motion of that block or board is actually this one. This is its direction of motion. Okay, this is the direction of motion. Now let's name these. This is force A, and that force is of 3000 newton at an angle of 30 degree with the direction of motion. And suppose this force is 4000 newton, and this is at an angle of for 75 degree, sorry, 80 degree with the direction of motion. Okay, how much? 80 degree. Isn't it? It seems that this force is acting at this block at almost 80 degree, and the upper one is applied, or upper one is acting at this body at 30 degree, right? So first of all, what you have to do, draw. Your task is, this is the way how the question is asked. Task: draw a scaled diagram and determine the determine the magnitude and result direction of resultant, direction of resultant. Okay, resultant force. So are you agreed?
Yes, sir.
Usually this is a 4 marks question. It's it has a very good weightage. So this is the space below, and here you will be given the space for answer. This, there would be the unit over here, and then here it would be written that direction, right? Usually you believe this thing that answers are asked in this way, or questions are asked in this way. Now I don't have scale. Sorry, I don't have protector and compass, but I have scale. But you people would have it. If not right now, in my next class, I would like that you people must have. Okay, first of all, at the top I will write the scale, because here I would the examiner have asked me write a scaled diagram, so I have to mention the scale. So what is scale? Either you can mention the scale over here, it is just like the graph, what you do in the graph. Here you have to mention the scale, right? Sometimes scale space is also given in your exam, in your here in your answer portion, right? How much scale should I place, or what scale should I plot? If I say that 1 centimeter is equals to 5 Newton, sorry, 500 Newton, then what will be the two forces? Then, then your 3000 Newton will be equals to how much?
6 centimeter.
6 centimeter, and your 4000 would be equals to 8 centimeter.
Eight
Am I right?
centimeter. Yes, sir.
Is it clear?
Yes, sir.
So, first of all, I have to use a scale, and I have to set that how much centimeter does it have, or what is the length of 1 centimeter. So I would love to draw this diagram on the right half of the, sorry, on the left half of my page, because resultant is on the right side. That's why I will start it from a point which is closer to the पानी दो. Okay, so this is the point. So this is basically the direction of motion. Are you agreed?
Yes, sir.
Right? So here is the point where I want to draw these forces. So this force which is at 30 degree, I would if I would have the D, then definitely I will show you how to use that. But as I do not have it, so I would just try to draw a hypothetical D. Okay, and by this hypothetical D, yes, this is 45 degree, and its half is over here, not half exactly. Here I have to split it into three parts, right? So this is your 30 degree, so you have marked 30 degree first. This is your 30 degree, and you have drawn 3 centimeter, sorry, how much length? 6 centimeter in this direction. So it is 1 centimeter, it is 2, 3, 4, 5, and 6. So it means that I have positioned this at wrong position, right? Are you getting it? Because
Yes.
I will not be able to use 6 centimeter, 1 centimeter, then 2 centimeters, then 3, then 4, then 5, then 6. So this is basically 6 centimeter from this point to this point. Are you getting? So this I have drawn a 6 centimeter line over here. Now again I will plot the D. I will not draw it again, but I am showing you that this is 90 degree almost. So it would be 80, would be anywhere 10 degrees behind it. So let's say if I have a D, I have to mention it because it would help you out to uh, represent it over here. Yes. So if it is D, then it would be 90 degree, maybe anywhere over here. Is it? Almost. So here, how much length I need? I need 8 centimeter. How much? 8 centimeter. So it would be 1, 2, 3, 4, 5, 6, 7, and 8. So I will draw an 8 centimeter over here. Now this is your 8 centimeter vector. This is your 8 centimeter length. So are you people agreed with me?
Yes, sir.
Okay.
Yes,
Now
sir.
what will you do? You will open your compass equal to 8 centimeter. This one, as I told you, I do not have compass, but I am showing you that I have to open the compass 8 centimeter, and I will place it at the head of this vector, I mean this 6 centimeter vector, and I will draw a line. Here I will make it, I mean, I will try to make it as accurate as possible. But I told you that for me it will not be as accurate as you can do that with the help of your compass. So 8 centimeter mean 1, 2, 3, 4, 5, 6, 7, 8. This is the point. So you can draw this black line till this, I think, till this, because it is 1, 2, 3, 4, 5, 6, 7, and 8. Yes, that is true. So I have drawn a replica of this 8 centimeter over here with the help of a compass, and then you will open the compass equal to 6 centimeters. Okay, equal to 6 centimeters. Place it on the head of this black vector, I mean head of 8 centimeter vector, and then mark an arc. And basically arc means here I will uh, place two arcs. One I'm going to draw with black one. That arc will be from the head of black vector, and then there would be a red one that would be on the from the head of the red vector. So here these two arcs are intersecting each other. So this is my 6 centimeter line. So now can you see that this is a parallelogram, as I advise you to prepare the parallelogram? And at what step I am, how many steps did I do? I did the scale, I did the vector diagram, I have completed the parallelogram, then I did three steps right now. Right now I am at the step number 4. I have to draw the resultant. Right, how to draw the resultant? Yeah, resultant is from the head of, sorry, tail of
From
tail junction to the head junction.
assumption. Yes.
Yes, so it would be something like this. Yes, this is the resultant. I would try my best to draw it. This is the resultant, right? So let's see how much length does it have. Step number 5 along with that. So it is almost 1, 2, 3, 4. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10.5. Is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10.5, and 10.6. Yes, exactly. Its length is 10.6 centimeter. How much length do I have? 10.6 centimeter. Is this vector diagram clear to both of you?
Yes,
Mhm.
sir.
Okay.
Yes, sir.
Now I got the length is equals to 10.6 centimeter. So what is the magnitude? Magnitude is something different than length. I will multiply this length 10.6 with this scale. That 1 centimeter is equal to 500. So I will multiply this with 500. So I will get, what will be my answer? Can you help me out?
So if 1 centimeter 500 Newton, then
Just multiply that. No
yeah,
need to
5,300.
5,000.
300.
300 Newton. It means this green vector is representing 5,300 newtons. So your answer is 5,300 Newton. Now is it clear?
Yes, sir.
Yes,
Okay.
sir.
Now the game is direction. So that's why I did not remove this D from here, this lower one, this red one D. I was actually in the favor of this D, that this D are the angle at which this is basically passing through, that angle is how much? Oh, maybe I would be able to have it. Wait. Yes. This is 0 degree. Oh, wow.
Yes.
Right. So I can rotate it. Wow, what a tool. So it is 21 degrees, right?
Yes.
Yeah. So this is basically, this is the line which is passing at 21 degree. So here I can say that this is 21 degree with the direction of original vector. So you can say 21 degree with x-axis or with direction of motion. Is it clear?
Yes, sir.
So this is actually what is asked in the forces. This is the top most question which is usually asked from the top forces topic. Is this clear to you?
Yes, sir.
Yes, sir.
Good. So I'm gonna send some worksheet to you and hope that they would be done by you by applying this method.
सर ये वो क्या नाम है, ये रिकॉर्डिंग नहीं है सर, ये भी भेज दें वो लिंक.
मैं recording भी भेज देता हूँ. Okay, and I have another video in which I have performed it practically with the help of compass and scale and all that stuff. I will send you the link of that video as well. So please watch that and it will help you out.
ओके सर.
Okay, see you then. Allah Hafiz.
अल्लाह हाफिज.
Allah Hafiz.